Arm waving.
I think it's on. Turn red, everybody.
Okay.
We're launching like a SpaceX rocket, ladies and gentlemen. Welcome aboard, stargazers and astronomy freaks. Welcome aboard our weekly SBAU Astro Hour, regular vlog and podcast for the South Coast Longtime Telescope and Astrophysics Club, the Santa Barbara Astronomical Unit. Live on Monday morning, anyway, the 27th of June, from our computer dens and man caves. It is Monday. It's 11 to noon every week. We use Zoom and we meet together, and you can watch us on YouTube. If you're new on the show and you love astronomy, even if you don't have a telescope like I don't, then consider joining our club. We are reconvening again, ladies and gentlemen, at Farron Hall at the Santa Barbara Museum of Natural History on August 5th. I'm the vice president of the club, proudly, Ron Heron. And today, before I meet the Brain Trust, we're going to talk about the nightly parade of planets across the sky again, starting with Venus and Mercury and Jupiter. Mercury's near Aldebaran. We're going to go inside Jupiter this show, perhaps. There's some stuff they're learning about the big giant planet you're not going to believe. Tracking Neptune, the ice giant, and a planetary nebula inside Hercules. And did you know you can access Hubble, get stuff off the internet from the Hubble Space Telescope? Also find out where Pan-STARRS comet is this week. So let's meet the gang. President Jerry running the show. Jerry Wilson, happy birthday.
Thank you. Happy birthday to me.
What he does again. Pat Forgy is his lovely wife. And are we in season 3 or season 4? I guess we passed through the 2-year pandemic and we were elected for a year of attending meetings live before that. So this would be number 4, wouldn't it?
I think so, yes.
Okay, well, it'll be in the fall. I guess December we elect new board members or keep the same. Chuck McPartland's on the screen, our outreach coordinator, Captain Outreach.
Good morning.
If you're in the club, I assume everybody who's in the club and has given us their email address got the list of things happening. There's a lot of stuff going on considering we're still in the pandemic outreach-wise. Where are you going next, Chuck?
That only goes to my outreachy list, actually, which is not everybody in the club and some people who aren't anymore, actually.
Well, then let's talk to the man that edits and puts out our newsletter, Tom Whittemore.
Good morning. Yeah.
Ex-Westmont science instructor. And bon vivant sourdough bread baker, Tom Whittemore, and his wife, Maureen. Chuck, of course, is married to another Pat. That's Pat McPartland, who is our merchandise manager. So Whittemore, the new, what is July newsletter will be probably hitting us in the email inbox before July, right? Which is.
Oh yeah, no, it's I have to. Yeah, it'll be out shortly. I'm doing a star story on Antares.
Oh.
And I'm kind of dressing it up for the article.
Okay.
Very quickly though, I just wanted to mention I finally did get Mercury this morning. Okay, in the morning sky. The planets in order, Mercury, Venus, Mars, Jupiter, and Saturn stretch way across the sky. So to see all of them. And I did this morning. I had to go to different parts of the house.
Well, then we're going to feature you in the highlights as we kick off Jerry's talking notes here in a minute. Let's meet one of our stalwart members, also the president of the Santa Barbara Theater Organ Society, Bruce Murdoch, who finally got on screen. Bruce, you're still repaired? Are you back with us fully?
I'm probably 80%.
Oh, so you're
the
still
trouble is my back starts to hurt after I've been standing for about 2 hours.
Okay, so you've still got that loner body they gave you. It's never. His wife is Bonnie, and we got lots to talk about, and only an hour to do it. And this is like the old luncheons we used to have. Jerry, you want to call up any of your silly science cartoons that you send to all of us? I'll try to match whatever you put on screen because there's some good stuff. And okay, the 2 bears. One's a polar bear, the other is a Cartesian
I like that
bear.
one. Yeah.
You're going to need to explain that a little bit to me. What's the Cartesian bear about?
Rectilinear.
Yeah, the Cartesian bear is just the old XY graph chart. That's a Cartesian plot.
Oh, okay, got it.
And then dimensional straight lines for the axis.
I may have been.
It's
told that.
Named
Okay,
after,
It's
Yeah.
kind of a math joke.
yeah,
I'm sure it is.
Yeah.
Heaven,
it's named the Cartesian coordinate system named after Descartes. Okay.
heaven,
And
heaven.
don't ever put Descartes before the horse.
That was also a pun from earlier, yeah.
Heaven forbid you should ever meet an arthritic bear like that in the wild. So what's next? Throw something up and we'll let the membership enjoy. Science can get silly. Here we go. I guess, let's see, which one is this one? Yeah, bad habits jars. One of them for cursing, swearing, and there's hardly made any. The other for explaining astronomy to people who didn't ask about it jar. Who was it? Tim Crawford liked that one, didn't he?
Yeah, he did. He commented about that.
That happened a lot. You force yourselves on people that don't want to. My understanding is
Well, at some social gatherings, people ask questions, and I just go on, and one thing connects to another that's of interest to me. And when
Yeah, we should
everybody
ask
starts
you what time
nodding-
it is.
yeah.
Yeah,
They ask you what time it is, and you tell them how to make a watch.
yeah, that's about it. Yeah.
Okay. Any others? You sent us about 7 or 8. Here comes another one, ladies and gentlemen. Oh, 3 scientists at the blackboard. One of them definitely gave it all. And the middle guy says to the third guy, Webster's blown his cerebral cortex. That often happens. That's far side.
Yeah.
Crazy.
I would have captioned this Webster's out of coffee.
Coffee. Okay, I can imagine that happens.
Okay.
One more, maybe 2.
One more.
The Swiss Reaper I liked. I'm not sure if you'll get that one or not.
Yeah.
Conductors.
This
three
is
kinds of-
This is a picture of boson.
Oh, that's right. No holes in this layer. There appears to be a large
Yeah.
oval ring of clowns around the Earth. And there's no
Mhm.
holes. Okay.
I guess you had to be there. Okay.
All right, are we done?
Yep.
All right. We don't get to see the Swiss Reaper or the coordinates. Oh, we did the coordinates. That's polar bears, 3 kinds of conductors. That was kind of cute. Since you, let me just make one quick announcement on behalf of our beloved museum. According to a thing that you probably got and I was received in my inbox, their science pub is returning to Dargan's Irish Pub downtown on Monday night, the 11th, 6:30 to 8. Dr. Rob Levinsky is going to speak. And we return, as I said earlier, on the 5th of August. And I'm working on getting our speaker to talk to us virtually on a big screen there, right? The screen we used to have for just the graphics will now have the actual speaker in LA. And we'll be in Farron Hall. It's going to be interesting to see if we fill that place or hardly anybody shows. What do you think?
It's still iffy, Ron. So,
Well, considering the opening night of the second Saturday Star Party, when you had what, 800? We might
No,
have
it
a
was-
huge crowd.
it was 500.
Yeah, that little hall holds what, 50 seats, give or take?
70.
All right. And you do owe us a pizza since we didn't have it at the last board meeting, so maybe we'll have it there. Mr. President, Mr. Whittemore, Mr. Murdoch, and Mr. McPartland, would we like to scan the sky? Venus is showing off. Talking points say it's, I don't understand this, 85% lit crescent. Now, if it were 85%, it wouldn't be a crescent shape, would it? If it we're
Well, it's
talking.
got a black crescent on it. 85% isn't black.
It's
Okay.
gibbous.
All right.
Yeah.
The
Give
disc,
us, give us. Does it say in the?
is this or what we're looking at? Is that Venus lower left?
Oh, yeah. Yeah. With,
This is from a previous year,
Yeah, this is
probably 8 years ago.
Yeah.
Not configured that way at all. Well, Mr. Tom Whittemore,
Yeah.
Dr. Whittemore, would you like to expand on what you saw this morning? Just guide us through it.
yeah, most of the mornings up here anyway have been fogged out, except Saturday morning, there was a spectacular, very, very fine crescent moonrise. That one came up first, and then to the right, or if you like to the south of the moon, came up Venus. Okay. And just when I was trying to find Mercury, which would be to the left of the moon, the fog came in. But miraculously this morning, I got to see Mercury for the first time in a long time because the fog didn't come in. It didn't come in that early. But basically the planets now, and again, they're in order. So as you go from left to right or from the north towards the south, you will see Mercury very, very close to the sun though. Venus, Mars way up high, Jupiter way up high, and then Saturn way up high. But they stretch over 100, I think 107 degrees, something like that. So I have to go to two different points in the house to see them all. Okay, to see them.
You could go outside.
Very pretty though, very pretty. The times I'm talking about, I noticed that Venus came up, and again, it depends on your horizon. We have some hills here, so it's going to occlude the planets for a little bit. But I saw Venus at about 4:35 roughly, and then I finally saw Mercury close to 5, and it's nowhere near as bright as Venus. Venus is extremely bright right now.
Okay, now Venus is near the Pleiades, which is M45 star cluster, whereas Mercury is not far from Aldebaran.
Oh, Aldebaran. Okay, so the bullseye of the.
And we'll get to that. I want to point out some features about the Pleiades here, but go ahead with whatever you want to say.
Are you talking to me or to Tom?
And whoever's listening.
Well, the Little Dipper is not the Little Dipper, right? This is a fake Little Dipper. Asterism up near Ursa Minor. This is from your notes. The crescent moon, as you say, is not blanching out the sky. Actually, last night, you could see both of them, right? 7 degrees to Mercury's upper left is Aldebaran.
It's early morning, Ron.
Morning, yeah. We're talking morning.
Okay.
Just before sunrise.
Yes.
Did I insert that nighttime? Or I thought I was just reading your notes.
It's still nighttime.
Okay, it's overnight.
Sun hasn't come up. But you can see, as you point out, you can see the Little Dipperness of the Pleiades star cluster. The rest of the handle up here is missing. Can you see my cursor?
Yeah.
Okay. But the feature that picks out the star cluster for me, when I see it, the recognition thing, is this bent line of stars right there. It comes down. That's the spotting feature. So
that's Allie's braid.
Yeah.
But if it's an asterism, what do they call it if it's not Little Dipper?
The Pleiades.
The Pleiades.
And
Or
what
the seven sisters.
Well, I only see 5, but there's 2 others somewhere, I guess, huh?
1, 2, 3, 4, 5, 6, 7.
There you go.
But I look in the sky, I only see the 5. Those 2 little ones.
Oh yeah, when you look with your naked eye, you might not see 7.
Yeah, I've mistaken it for a Little Dipper many times. Okay, and it's one of the M numbers. It's 45.
Yes.
SCA. Yep. Okay, dokie. We also have, I don't know how far, you say they're all lined up. What's missing?
The planets are lined up.
Well, you said
nothing's missing, Ron. Nothing is missing. Uranus and Neptune are up there too, but they're not in order of their distance.
Right.
Okay, and
you
Saturn.
can't see the naked eye.
Right.
Well, as long as we're talking, let's see. You did have something about Neptune, magnitude 7.3, 5 degrees due south of Lambda Piscium. And just 2 degrees, no, 2 something across. 2 arc seconds across. That's not very big, is it? 100 arc seconds or 60 arc seconds in an arc minute?
60.
60.
And then 60 arc minutes inside a degree?
Right.
How in the world can you measure that? Do you have devices on your telescopes that tell you how many when you look?
Micrometers.
You can get eyepieces that have reticles in them that can give you a scale, but you have to calibrate the scale for your scope and eyepiece by by looking at something you know the size of, like the moon. This shows a little bit of what Tom was talking about the planets lining up. There's Mercury, Venus. The rest of them are stretched up here.
Yeah.
So, and this shows Venus in Taurus below Pleiades.
Hmm.
On
Yeah.
our scopes with the Orion hand controllers, you just read it off the hand controller
Mhm.
where you're at.
And Mars
Yeah,
is in there somewhere?
Yeah, but
Yeah,
Ron was
but-
talking about figuring out what the angular extent of something was.
Yeah,
Plus,
Oh, all right. Okay.
I don't suppose they're in order as in from in to out on the sun, starting
Yes,
with
they are.
Yeah.
The naked
They
eye
are.
planets are in order.
Mhm.
kidding.
Yeah, and by the time you could see Mercury in the morning, there's no hope that you could see the Pleiades. It's too glowy. It's way too glowy.
Okay.
I looked out about 3 a.m. and Jupiter was by 4 or 5 degrees in the east,
Yeah.
very bright.
Yeah. Well, I'm talking 5 in the morning.
Oh,
So,
okay.
Yeah, you have to wait for those close to the sun to come up.
right.
Saturn's rising pretty early, actually.
Yeah, it is. Yeah. And again, there was a beautiful crescent moon to the left of Jerry's chart of Venus. It's very, very pretty.
Mhm.
And it just turned out that's the thing I saw first. And it's partly because of the topography of the hills here. Okay.
Now, this shows not only Venus and the Pleiades, as we saw, but it shows the star Aldebaran.
Mhm.
And that apparently, and I'm not the expert on previous languages, but that means Aldebaran means the follower.
That's
Because
right.
apparently it follows the Pleiades across the sky.
That's
This is the eastern horizon down here. So things are moving up this way, and that's certainly true that Aldebaran is rising after
Yep.
the Pleiades and stuff.
Yep.
It points out that Pleiades or the Aldebaran is 1.7 times the mass of the sun, and it's 43 times bigger in diameter. So that if we placed Aldebaran where the sun is in our system, then the star would appear to be 20 degrees across in the sky. Whereas our sun right now is half a degree across in the sky. So it would take up a significant part of our sky.
And it would be tickling Mercury.
Oh, yeah.
Definitely get a fire alarm if that were to happen.
Yeah, some
Wow.
people say that the Pleiades, first of all, Aldebaran and Jerry's, of course, right, the follower. Aldebaran is the eye of the bull's eye, red. And then they say that the Pleiades rides on the back of the bull.
There's also an American Indian or a Native American story of the Pleiades being the ladies who ate onions. They were out searching for food and they found a patch of wild onions and they ate a bunch and they came back to the village and their husband said, your breath stinks, go away. So they went up and became the stars. And then the Hyades there with Aldebaran, that cluster that makes the face of the bull, is the husbands following him through the sky, haven't caught up with him yet.
Wow. I gotta tell you, what about Saturn? It's there in there somewhere. Can you?
It's after Jupiter in the night
Yeah,
sky.
I don't have a picture of the things in line across the sky to show. I could dig one up if you want. But I think we showed it a number of other times, so I didn't think it would be a big topic tonight.
Saturn is way over in Capricornus.
Yeah,
But it's in line with the others. They're all in the
Yeah.
same.
it's starting to get where we're going to start seeing it around midnight.
This sounds to me like it's a very rare event that all the planets would be lined up on one side of the sun.
That's not what's happening. They're lined up in the sky. They're not all on one side of the sun.
Really?
Yeah.
Yeah.
The sun isn't, well, the sun's over below the horizon to the west.
Yeah.
Are we looking east or west or where?
We're looking east. It's below the horizon to the east, but some of these planets are on the other side of the sun, and we're just seeing them lined up apparently.
For example, the typo I had in that referred to Venus as presenting an 85% lit crescent. It is actually an 85% lit gibbous phase, and it's on the other side of the sun. Otherwise, it would have passed through a half illuminated disk and be a crescent now. So it's on the other side of the sun. I don't know exactly where Mercury is, whether it's on our side or the other side.
So are you saying that a crescent isn't necessarily less than half of the?
No, it is necessary. It is less than half.
Yeah.
Well,
Well, this is a gibbous phase.
Yeah, it was incorrect. The word crescent in there is incorrect.
oh,
Got a black crescent.
Yeah, you can, that's a technicality. Good try. Good save, try.
So 85% means it's almost full.
Right.
Yeah.
This thing
So,
is a
so Ron, when Venus comes around the sun and becomes crescent-like, it's brighter because it's bigger. It looks bigger to us and it's brighter.
Closer.
And closer. And Galileo noticed that, and that was one of the reasons that he said that, the sun must be at the center of the solar system.
Well, considering all the planets, certainly us inner ones are on the ecliptic, when the inner planets to us, which would be Mercury and Venus, go on the other side of the sun, do they disappear? Or do we ever see them across?
We're seeing that now, Ron. We're seeing that
Really?
now.
When they're exactly on the other side of the sun, they're behind the sun.
Yeah.
But we can see across the top, or do we see across the bottom of the sun?
We're seeing around the side.
Yeah, and you could see Venus if it goes, if it happens to be at the same longitude, I guess you'd call it, as the sun, you can see it above and below. The trouble is it's so close that it's dangerous to try to do that. But that's the only time you see it fully illuminated.
Yeah.
Okay.
And it's always pretty close as it goes by on the other side. Interesting.
Now, I'm not showing the wrong slide here. I just was preparing for the next topic before we got off on the tangent there. This shows, this moves us to the evening sky and the constellation of Hercules.
Yes.
It's 10 o'clock in the evening, and this was June 28th, so tomorrow. The bullseye here shows NGC 6210, which is a very interesting planetary nebula that I'll show in a minute. But this in Hercules is a very rich part of the sky. This is a planetarium program called the Sky 6. And you can see M13 up here, which is a very nice globular cluster. And these faint little blurbs in here, those are galaxies. And then there's, if you can see real close, there's two little round circles right there.
Here we go.
Right there.
Larger.
And those are planetary nebulas. Now this is a planetary too, but the sky, the program doesn't show it. A lot more galaxies in the background. As a matter of fact, if you take a picture, an image of M13, or you have very good eyes at a dark site, you can see a nice galaxy in the background of M13.
Yeah, 6207, Jerry.
Okay. So, having said that, let's see if I can find the picture of 6210.
Yeah, and that's very good eyes through a telescope, not very good eyes naked eye.
Yeah, yes.
Right.
Yeah, I meant through a telescope. Yeah. This shows the planetary 6210. And so it's got quite a complicated shape. It could be the way it blew up or threw off its shells, not all of a spherically symmetric, or it could have an axis of spin or a companion that biased its gas distribution, and we're looking at it through some odd angle. So it's quite an interesting study. There's a lot of these things out there because there's so many average size stars like our sun. And that's how our sun will end, as a planetary nebula without going through a nova stage. So this is just a belch, not an explosion.
It looks like it might have some fair amount of proper motion and be running into some interstellar stuff too that's interfering with it.
Yeah, a lot of things are possible. Each case has to be taken independently. Now today I'm going to show a lot of pictures that have no stars in them.
Jerry, do you mind if I just mention just a little quickie here while you're there?
Go ahead.
Oh, I was just going to say that Hercules is also known as the solar apex. It's where our sun is dragging the solar system. So we seem to be headed that way to the solar apex. So I believe it's near the keystone, if I remember right. Okay.
Yeah, that's our motion through the galaxy.
That's right. That's all it is. Yeah.
Hercules, the strong man. He's
Strong
pictured.
man,
I always called it the hunter, but
No, that's Orion.
That's Orion.
I think that is Orion. Yeah.
Yeah.
What Tom is talking about is the keystone, is this part of Hercules. You see it's shaped like a trapezoid. And so that would be the keystone that you drop in the top of an arch to keep all the stones from falling down on the architect's head.
Yeah, I've never understood how that.
When they first developed the arch back in ancient Roman times or even before, the tradition was that when you took the wood forms away, the architect would stand under the arch. And that would incentivize him to possibly over-design the strength of the structure.
And I guess
Maybe.
Yeah.
And I guess they do something similar in domes, don't they?
Mhm.
Wow. Your notes bring up the dumbbell nebula, turtle. Let's see,
Turtle.
Beta Hercules, the turtle rivals M57, the famous dumbbell.
That's the one I just,
M57 is the ring, Ron.
Ring,
M27 is the dumbbell.
And once again, we call them planetaries because there's enough stuff there to make new planets, or
No,
because they
no,
look like planets?
No.
It has nothing to do with planets.
Nothing to do with planets. When they were being discovered, they looked green and round, a lot of them, because there's a lot of oxygen emission and your eye is sensitive to green. And that was around the time they had found the planets Uranus and Neptune, and they look similar. So they said clouds that look like planets.
Wow, and there's a bunch of them.
Oh, yeah.
Okay. Evening sky, Hercules, sunset, got it. Where are we going now, Mr. President? Now,
where would you like to go?
I'd like to go to Jupiter because you really, since we're talking planets, well, of course, we're coming back to the solar system again, but at some point we could really get into some stuff that is coming in from the Juno orbiter, and somehow they're figuring out what's inside the giant gas planet.
Yeah, that's a
Mhm.
little tricky to do, but we'll do it. This, of course, is a picture of Jupiter.
Pebble accretions, gobbling up planetesimals.
Yeah,
It's taking little Earths. Let's see, what 11 to 30 Earth masses could be in the middle of Jupiter. Look at that.
yeah. This is Jupiter, and you see it, and we've up until we had Juno and Odyssey around Jupiter, we've never been able to really penetrate what's underneath the clouds.
Jerry, Odyssey is a spacecraft around Mars. So I'm wondering.
Galileo.
Galileo, that's
Galileo,
it.
yeah.
Galileo, yeah, thank you.
That's in your notes. Otherwise, I wouldn't have known it. I gotta tell you.
Let me find the other one here. Illustrates the point. Now, this is the shape of the Earth. In terms of its gravitational field and its mass distribution. It's much more dramatic for the moon. And what has happened is, and you can figure out the shape of things inside by the gravitational field from orbiting satellites. Not because they look at anything, but you measure the speed the satellite is moving at as it passes over regions of the planet. And for Jupiter, we've got two things going around it in elliptical orbits, and they're broadcasting information to us. So as they fly around, we can monitor the Doppler shift of the signal they send to us.
Actually,
So
we only have one. We only have one right now, but
yeah, currently one right now, but there were two that we measured. Yeah. Yes. And so we measure the Doppler shift of that thing, and we can tell because the gravity it's passing through is what determines its orbital speed. And so we look for slight variations of the speed. And that lets us map how the mass is distributed inside of a planet. And for the first time, they've got a definitive theory about what is inside Jupiter. And the speculation is, I'll just be brief and then you guys can chat it up. Is that the planet Jupiter grew by accreting, because of the amount of atmosphere it has, it grew by accreting other planetesimals, planets that were formed, and caught them and made a central body out of them that accumulated the gases.
Can I say something about this picture on the screen right now?
Yeah, this is the Earth.
On the lower left, on the other side, almost the other side, is looks like Australia. Those lumps assuming the land masses are lumps, they're not that big in real life, but what does that mean? There's less gravity there or more gravity?
The red is more gravity, the blue is less gravity.
Okay. And if we could see a side view of North and South America, they'd be lumped up too, like Australia
Yeah.
seems to be. Oh,
Yeah. You can see the masses of the mountain range of the Andes. You know, that's extra dirt all piled up, and Colombia up there near Panama.
yeah.
And in the northern part of the U.S., the Rocky Mountains are particularly dense.
And so that's how they learn what's inside Jupiter. Pretty
Yes.
Gobbling up planetesimals. So it didn't start out, they don't think, it didn't congeal at the beginning as a rock with a bunch of gas.
That's the pebble theory, and that doesn't fit the data that we're receiving.
Well, now, do you see,
to refine that a little, what they were saying before was it sort of did its pebble accretion phase and got to about the size of the Earth, and then it started to suck gas, and that's what let it grow really big and have a huge atmosphere. But now they're finding there's more core than they expected, and so they think what they thought before was the gas kind of kept you from collecting more of the rocky stuff. But it turns out it doesn't, and so it collected much more of this rocky, dense stuff on the interior by sucking up planetesimals that were in the neighborhood.
Well, wasn't there a theory at one time that said there was a giant ball of incredibly compressed hydrogen that turned into a solid?
No, not a solid, but a metallic hydrogen.
Yeah, the phrase when I was studying astronomy as an undergraduate was that Jupiter had no solid surface. It was just denser and denser fluid or gas that went from a gas to a liquid to essentially a solid with no strong interface. Now it appears with these concentrations of mass at the center, that's not the case anymore. It may have a rocky core.
Right, although there was a previous result from Juno that said those heavier elements tend to be dissolved in that metallic hydrogen, so it's not like a solid lump.
Right.
But would helium be right above it in another layer, and the higher the element, the further out it goes? Or hydrogen being the simplest, number one, is in the middle? Is there any reason?
No.
It's just because it's mostly hydrogen.
Yeah.
We have iron in the middle of Earth, right? That's why we have a magnetic field. Okay, but there's no iron in Jupiter, or
yes, there is.
Yeah.
Oh, I'm sure there is.
They didn't mention it. Okay.
There's the iron core of other planets that it's sucked up.
Yeah, the stuff they're talking about as being the dense stuff includes iron, quite a bit of it. And it does have a very strong and very complex magnetic field.
But they also happen to be very large, and us rocky planets happen to be very small. I wonder if that's a given from now on throughout the universe. If it's small, it's going to be a rock with a light atmosphere around it. If it's large, it's going to be mostly gas, or at least that's what we see.
That's a reasonable assumption, but that's not necessary, I don't think.
I think at this stage, we're working out those generalizations.
But we've never seen a planet that's all rock of the size of Jupiter or Saturn, have we? Or Uranus and Neptune, for that matter.
Not that we know of.
Yeah.
I mean, we've seen them, but we don't know what they're made out of in some cases.
Yeah.
And well, they're determining what they are around distant stars, exoplanets, and most of them are gas giants they're finding. Even
well, they're assuming that, but you gotta manage to get a spectrum to know for sure.
I got you. Interesting. Okay, that's fascinating stuff. Incidentally, I read or heard, I'm not sure where they are in my notes, that Jupiter, if you lock in on it with your telescope, has 3 of its moons to the left and the fourth one that we see to the right.
That's only at one given moment.
Right. They all move around. Sometimes they're all 4 on one side, sometimes they're 2 and 2, and sometimes they sort of disappear because they're behind or in front of the planet.
Okay.
And that picture you had of Jupiter had a nice moon shadow on it.
Yeah.
Well, normally that's what, Io?
Can be Io, Europa, Ganymede, or Callisto.
Yeah.
The most innermost is the closest is Io, isn't it? The volcanic moon. Wow. There you go.
Yeah, there's the shadow of a moon.
Has the red dot or red swirl, the red spot changed over the
Oh.
years?
Oh, yes.
How?
It's faded. It never used to be this dim. It was
Well-
quite strikingly orange when I was a kid. Of course, my eyes were a lot better too.
Yeah. It's gotten more orange in the last couple of years. It went through a couple of years where it was the great flesh-colored spot, but it's
Yeah,
getting
that's
more
right.
orange now.
How does science know that it's several hundred years old, not 5 years old or 10
Because
years
we've been
old?
looking at it for hundreds of years.
Yeah.
Really?
It's an easy feature to spot.
Even in Galileo's time?
Well, I don't know with his telescope.
Yeah.
Yeah, I don't, he could have been able to see that, Ron,
Yeah.
with his little telescope.
His
I
telescope
think his
worked
best was
very
30.
good.
Or I think his best scope might have been around 30 power.
Yeah. I think we've been observing it for over 200 years, but not 400 years.
Mm-hmm.
Wasn't
So-
there, wasn't
Go
there,
ahead.
wasn't there a similar white storm on either Uranus or Neptune? I think
Yeah.
Uranus.
Neptune.
And it went away, didn't it? Disappeared?
Yeah.
But it was a storm. Bruce, are you with us?
I'm here.
I don't see you. You got anything to say to add to the conversation, my friend?
Oh, I'm just listening.
I can see you fine.
Okay.
Now this shadow here is produced by one of the moons. And because of the illumination here, this is the night terminator and this sharp edge is the edge of the planet. So we're looking off center a little bit. It's not at opposition, which means that the moon that's producing the shadow is off here somewhere.
Mm-hmm.
Oh, okay.
So it's out of the picture or it's hidden. Well, no, you would see it.
That's why the shadow is elongated
Is it elongated?
slightly.
It's
Yeah,
just,
slightly.
it's very slight. I was looking for that fact, yeah.
If you get into that, it's hard to see in this picture, but Jupiter rotates so fast. 10 hours for a complete rotation. And it's so big.
Yeah.
It's moving very fast. And this is not, it does not present a circle to us. It's an oblate spheroid.
Mm-hmm.
So it's much fatter at the equator than it is from pole to pole. And you notice this if you try and draw, make a drawing of the planet, which I did a lot when I was a kid. You can't fit the stuff, all of it. If you draw a circle on a piece of paper and start filling it in, you quickly notice that it doesn't fit.
It's the great double cheeseburger in space.
Yeah.
Well, if there were some way to land on it, you wouldn't probably weigh as much as you'd think because of the 10-hour turning, especially if you were, I guess, on the equator of Jupiter. You might be tossed out or at least lighter.
If you were up there on Jupiter and you could survive it, you would weigh 12 times what you weigh here on Earth.
Yeah, I used to think of that as a
You wouldn't be
kid.
as tall.
No,
Well, can you name those planets? Those moons? Europa, Ganymede, and Io are to the left. Callista is to the east.
yeah.
Doesn't matter.
Well, I don't know where but those are the right names.
That's on like Tuesday morning, I think.
Mm.
Is it Jupiter or Saturn that has a larger moon than our moon?
Lots of planets. do.
Pluto.
Pluto has
No, not Pluto.
Charon is bigger than our moon.
No, it isn't. No, even
Is it?
Pluto is not bigger than our moon.
Oh, I was wrong. I thought I made a mistake.
Yeah.
But our moon isn't the largest in the
No.
solar system of moons.
It's
Oh, I know
large
what to
relative
do,
to
yeah.
our planet, but it's not one of the largest.
I wonder
Yeah.
when a moon ceases being a moon and becomes part of a binary.
That's a good question.
Yeah,
I mean, are there binary star systems, which is really one huge star being orbited by a little star, and therefore it's a moon?
No, it's not
Well,
called a
there's-
moon, no.
as long as they're both stars.
As long as they're both stars, they're binary. Okay.
I don't know if you had a planet orbited by a dwarf planet, if that would be called a double planet or what it would be.
That's the next argument.
Yeah.
I
And all
have-
these things are kind of semantic tricks. It's not, there's really a continuum of all these different things. And where they choose to put a line to call it one thing or another causes some controversy sometimes.
I only recently learned that asteroids have moons. Not a lot of them, but I also
Well,
learned,
Quite a few do.
yeah. But unlike those scenes in Star Wars, if you hit the asteroid belt, you're not going into a teeming field of rocks everywhere. They're many
Oh.
miles apart, right?
That's pure Hollywood.
Thousands.
Space is empty.
Well, pure Hollywood is those trips into space where the stars are going by you. It just that's never going to happen unless you.
That's why we call it space.
Space. Okay. You want to
So
go?
this is a picture of the region of Pan-STARRS, which is on the 28th, which is tomorrow. It's right around in this area here, passing through Ophiuchus, the neglected zodiac sign. This is, well, Bernard's star is in this region too. But one of the interesting things about it, if you look real close, you can see all these little red circles on this planetarium program. So you can see them here, all over. Those are all planetary nebula. There's a very nice star cluster here, M14. It's a very rich area. The great photos, if you take a picture of Pan-STARRS, it's passed through lining up with its tail, so it's now got a tail off to one side.
Yeah, Ophiuchus has a whole bunch of globular clusters right across the belt of the thing.
Yeah, there's M12, M10.
Yeah.
Can you enlarge it again, Mr. President? Just bring it in close, and I had one question, if you don't mind. There's a red line. That's not the tail, is it?
These red lines?
Yeah, well, that's
That's the constellation outline, Ron.
Yeah.
Oh, I see. Okay, there's red lines everywhere. Okay, now I see it.
And it's one person's opinion of what the constellation lines look like. This program doesn't draw them the way I'm used to having them drawn.
Well, I'm sorry, but I don't happen to see the comet. I see the words comet.
It's not there. I'm just showing the region of Pan-STARRS. The program that I have, the Sky 6 in this case, was written probably 2 decades ago. And Pan-STARRS was not discovered then, so it's not going to be in the catalog of objects. Now, you can't modify the catalog if you're so inclined and put it in, but I was not that interested in doing it. So I just put the words in right about where they are.
Jerry, comment time, just comment.
Yeah, go ahead.
Okay, I was going to say that star up top there, Ross-Al-Hague, I was actually going to do the little star story on Ross-Al-Hague. It's a very interesting star and does have a companion. But anytime you see the word Ross in Arabic, it means the head or the top. And Ross-Al-Hague is the head of the serpent bearer or serpent collector, Ross-Al-Hague. So that's kind of the tip top of that constellation. That's the fellow's head.
And really, Sebel-Rai is usually one of the shoulders, I think.
That's right. That's right. And Ross-Al-Hague is not too far from that star in Hercules called Ras-Al-Gepi, which is the head of the needler. So again, anytime you see the word Ross, it's head. In fact, just interestingly, I like to cook a lot of Middle Eastern stuff now and then. And one of the collections of spices I use is called Ras al-Khanut, which means top shelf, top of the house. So you see that word in cooking, you see it in astronomy. It's pretty cool.
Okay.
Did anybody pronounce the name of this star? Cebal-Rai? Sebel-Rai?
Sebel-Rai. That's the one I just mentioned as the shoulder.
Yeah.
Oh, I heard. Okay, magnitude 2.8. You got to find that, and just northeast in the quadrant of the constellation Ophiuchus, right?
Yeah.
You see, it's more golden, Ron. A little more golden compared to Ras-Al-Hague.
Okay, but forgive me for not remembering, what is Ophiuchus pictured as?
The serpent bearer.
Yeah, serpent bearer. He also is associated with Aesculapius, the symbol of healing. Chuck, you probably have some nice comments on this guy, because you were born, the sun was in this constellation.
Yeah, the story was he was a physician, and back then they thought snakes lived forever because they shed their skins, and that gave them new life. And so he supposedly studied snakes and found the secret to immortality, and he was making people immortal, and the gods got pissed off at that and put him up in the sky holding his snake.
And Chuck, isn't it true that you were born when the sun was in this constellation?
Yes, okay. I'm an Ophiuchus.
So that's your sign.
Yep.
Technically, yeah.
But
So
a serpent bearer would be what? An East Indian with a turban?
No,
Snake
no,
charmer?
he was a physician that studied snakes. So they showed him holding a snake.
Yeah.
Ancient Greece.
And that's up
Yep.
there portrayed in the
Yes.
planetarium.
Mhm,
Guy
mhm.
holding a snake. Why don't I remember that?
Okay, this grouping of stars right here is IC 6554. Is that right? Yes, 4665.
Yeah.
It's an open cluster, and if you took all the stars and combined them together, it would be a fourth magnitude object. So it would be a
Wow.
naked eye object. But it is spread out, so you need a telescope to see it. The
Nice with
Pan-STARRS
binoculars,
comet.
I bet.
Oh yeah, binoculars are good.
Mhm.
The Pan-STARRS pass is going this way. It passed through about a week ago. It went through here. A spectacular opportunity for good pictures.
Yeah.
And you can see all these little white smears in the background that look like stars that are elongated. Those again are galaxies.
Yeah.
So
It's a very rich area.
it is.
It lies above Scorpius, you know. So you see this guy come up first, then you see Antares next.
And this
Scorpius
is
is now in the sky.
What'd you say, Bruce?
I said Scorpius is now nice and high in the night sky.
Very, yes, it is very high.
And it's globular cluster central up here.
Yeah.
Yeah.
I picked a bunch of them off in open cluster, sorry, Chuck, with my little binoculars the other night. It was nice and clear.
Scorpius has a feature that I've only seen from the gun club up on the crest of the Camino Cielo, and that is the false comet
Oh, yeah.
Yeah,
down
that's
around the Stinger area.
Mhm.
This is what the sky would look like. It doesn't show the horizon, so it doesn't mean much, but at 10 p.m.
Mhm.
So it's well positioned up in the sky for this.
Yes, yes.
Huh. And M14 is in there somewhere, or did we mention it? Just, I missed it.
Yeah.
Yeah, it's a globular. That's a pretty globular.
Globular clusters.
Mhm.
So my understanding, I'm trying to learn, gentlemen, globular clusters are not planetary nebulas.
No.
No, they're old stars.
Yeah, they're round balls of stars, star ball.
Hence the word globe. You know.
Yeah.
Whereas a nebula is just gas.
Yeah.
Flame or lit up or however you want to say it.
Technically cloud in Latin, technically.
Okay.
And in older references, you'll see galaxies referred to as galactic nebulae because they didn't know they were other galaxies.
I just saw a YouTube video that said they think there's something on the other side of our galaxy that we can't really see with a normal telescope because it's right through the gaseous middle.
There's a lot of things in that category.
But they're using radio telescopes and radio waves or infrared.
Yeah, radio to get through it. That's how we spotted the black hole at the center of our galaxy, was looking through the gas and dust by radio waves.
Gotcha. Well,
This
now,
is, go ahead.
very interesting part of your talking notes, Mr. President, was people can avail themselves of interesting stuff off the Hubble online.
Oh, you want to do that? Okay.
Have you ever done that? Any of you used Pitt's Liberator,
It's Liberator.
Pix Insight, or Photoshop? Photoshop? Really? It's
Yep.
and then it goes into something called the Meropa Nebula. Why is that?
This is okay. We're going to do that.
Okay, Hubble's data available online, and
This
someday.
is the Merope Nebula,
Okay,
and
This is in the Pleiades, Ron.
yeah, let's go back to that.
hey, there's no stars in the nebula. It's all gas. There we go. The monolith from 2001 Space. Oh my God, it's right in front of me.
You often see stars in nebulae, Ron, because they're where stars are being born quite often. But in this case, it's different. It's a dust.
So this does not show. This is the Pleiades, of course, and it does not show the Pleiades nebula, but you frequently see this nebula, gas and dust. Do you know which star is Merope?
It's one of the brighter ones, but the brightest one in the center there is Alcyone.
Okay.
So
And
it's
one's
one of the ones
Electra.
off to the right.
Okay. So one of these stars, and there is a nebula associated with the Pleiades, but it's not from the Pleiades, and the Pleiades did not form from the nebula. The Pleiades as a cluster are just passing through a nebula.
Right, that's right. Mhm. It sort of appears blue, appears blue in the scope.
It's
Yeah.
because it's mostly dust and it's scattering blue wavelengths of light. It's not hydrogen being, fluorescing.
Right, right.
Well, we had to have been created, our solar system, out of some sort of nebula 4 billion years ago.
Yeah, very much like the Orion Nebula we're speculating. Now, this is the Merope Nebula. And you notice there's no stars in this picture. A few years ago, some amateur or professional image processors worked out an algorithm to remove stars from a picture. So you can show a picture of the sky without stars in it. And that's what you're going to see, start seeing more of these days. This is the Merope Nebula with the stars removed. So it just emphasizes the gas flow. And the talking points discuss the different types of gas and dust that are here. There's rays here coming out from a star that is reflecting off the nebula. This whole thing is reflected light. And so there's stuff down here that's fanning out, but there's stuff up here that's straight streaming.
Isn't that star called the Merope star?
The Merope is the star that is embedded in this nebula.
That we don't see.
It appears to be.
Okay. And they're like 0.06 light years away from the cloud. That's pretty darn close.
Yeah, they're not far away. This is E.E. Bernard at the turn of the 1900s labeled this as, labeled it as Merope Nebula. It's also known as IC 349. It's dust and gas. It's moving about 11 kilometers per second. And as you point out, it's about 0.06 light years away from the cloud. So it's equivalent to 3,500 astronomical units.
Yeah. But what we're looking at is the remains of a star that hypernovaed.
No.
Oh, it's not what that is. What is it? Just plain
Just
old
interstellar stuff.
Really?
Yeah, this is probably from older red giant stars tend to barf off gas from their outer layers, not necessarily exploding, but they give off particles like this. These are little silicate and carbon particles.
Right.
Do you suppose
This part down here that's flared out, that's the part that's near Merope, the star. And this is gas that's streaming in, and as it comes close to Merope, it spreads out into this nebular form.
Geez, that's weird.
Yeah.
It doesn't look round, or that's strange to see something not totally round. Even the aftermath of a supernova explosion is round, pretty much, going out into space. Now, are there planets and stars being made in this sucker?
Probably not.
Doesn't look very dense.
Yeah, I don't think so.
These are just fine particles, and the stellar winds and light pressure from these stars is what's causing it to have this streaming look.
Look at it as a dust storm.
Yeah.
Okay. And the reflection nebula, wispy effect. Merope is the name of some long ago astronomer, I guess.
No, it's one of the sisters in mythology, one of the seven sisters.
Oh, okay. 11 kilometers a second. And that, okay, you give us everything we need. IC 349 is Bernard's nebula, right?
Yeah.
Okay, what is this?
This is NGC 4485. It's an irregular galaxy located in Canis Venatici.
Okay.
The point of this is that this is data that an amateur took off of the Hubble Space Telescope site using a program called FITS Liberator. FITS Liberator is freeware. It's available. It started out about 20 years ago as a plugin for Photoshop, but now it's up to version 3, and it's a standalone program. FITS is a scientific program that's used exclusively or made exclusively for astronomers because it has a very flexible and thorough table of data that goes with it. So it's a 2-part program. It stores the 2-dimensional data or multidimensional. This is of course an image, a two-dimensional image, but it's also capable of storing a three-dimensional image, which is referred to in the business as a data cube. And
it's a file format that allows you to store all kinds of data.
Thank you. And there's two kinds. One's the data itself, and then the other is about the data. It's like your camera setting and your camera type and the filters used and stuff.
Metadata.
Metadata. Okay. It's very handy, very thorough. There's a number of other things that do it now, and the new Photoshops and PixInsight probably don't need Fits Liberator so much, but you can go to the Hubble sites and find these images, and then you can process them yourself. It's a little tricky in the sense that the Hubble Space Telescope does not use the RGB format that amateur astronomers like to do. So the filters on the Hubble are specific for certain scientific investigations, but you can fake it. You can put it together, and all these star images are false color images anyway, so you can make them anything you want. So, but this is one where an amateur has gone after that. And let's see if I have another one.
That one nebula on the right side of it looks very much like the Tarantula Nebula.
Oh yeah. Oh yeah, what we just looked at too, the Merope Nebula, that was also processed using Fits Liberator, PixInsight, and Photoshop 2022. If you use Photoshop, you know that they went up through Photoshop 2, 3, 4, 5, and 6. And then after 6, you don't buy the program anymore and put it on your computer. You subscribe to it in real time. So there's a small charge of $10 a month or something. I just made that up. I don't know what the actual charge is, because I have a version of Photoshop 6. And so because I don't use it that often. So
I think I had version 4, and with operating system upgrades and things, it finally went away.
Yeah.
I just said that when we used the 61-inch in Tucson to take images, they were all stored as FITS files. Okay, but it didn't give us FITS, but they were FITS.
Is the Hubble still producing? Isn't it soon to be deactivated?
Nope, it's still producing.
No, I think it's going.
Well, it'll run until it runs out of gas.
Yeah, and then, but if Elon gets his Starship operating, that it has plenty of capability to reach the Hubble and refuel it or upgrade it.
But not the Webb.
So it could probably reach the Webb too, but the Webb was meant to be self-sufficient in 2 stages, one with its super low coolant for about a decade or 2, and then after that it'll run at a higher temperature, but still interesting.
And some of that stuff will be available to us someday, I imagine. Really outlandish.
Next month, I think July 12th or something.
Yeah.
July 12th is one of the first releases, and the Santa Barbara Museum of Natural History has been selected by NASA as one of the sites that gets the data right as soon as it comes down, gets the images right away.
Ooh.
And they were going to have a big opening in Fleischmann, or I guess Fleischmann's busy with the Jet and Mineral show, but they're going to have a big show maybe in Farron as the image came in, and it turns out that since the pandemic, they've transitioned to a different work week, and Tuesdays, like July 12th, is when the museum is closed.
So all those spaceborne telescopes have rockets that keep them aligned and turned and all that.
No, you don't want any kind of propellant gases around the Hubble. So it uses reaction wheels. It has these big wheels that are spinning, and by clamping down on those or speeding them up, then you can adjust your position.
Well, I just heard
but
Bruce.
It can't boost the orbit.
I just heard Bruce Murdoch say run out of gas.
That was a euphemism.
Oh,
yeah, exactly.
But the Webb doesn't have it. Does or doesn't use rockets?
The
No,
Webb
because they don't want the rocket exhaust to condense on the mirror.
Okay,
Right.
And so they got the similar
reaction wheels.
reaction. Are they
Right.
like ball
There's
bearings?
6 reaction wheels. There's 2 primary one and a redundant one for each of the 3 axes needed in space.
How many have they lost so far?
None.
Oh, really?
Yeah, they're doing good. I don't think they've lost any reaction wheels. The Hubble has lost a few. I think it's
Well,
running.
they discovered why they fail, and you get micro welding of the ball bearings to the races. And when they put in ceramic balls, that problem went away.
Yeah, another fix is to use magnetic bearings where things never actually touch.
Okay.
Yeah.
And Hubble, I think Hubble is down to only 2 working gyros, but I'm sorry, I'm thinking of I think Kepler, where they lost their gyros and they were actually using solar pressure from the light reflecting off of it to help position it.
But when the Hubble locks in on something, it has to stay locked in, even though it doesn't see a thing for a whole trip around the other side of the Earth. And then it comes back in the viewing area again, doesn't it? Webb won't have that problem. It's not orbiting that close to the Earth. Gentlemen, we have run out of time, but it was awesome. And I learned a lot, and looking forward to our reopening in Farrand Hall at that great little museum of natural history up in Mission Canyon that we all so adore and love.
Yeah, I'd say stay tuned on that and watch the web page, because that may not happen. We'll see.
Oh, okay.
We're still discussing it vis-a-vis COVID.
All right. Well, I've got a lady set to talk to us from UCLA again, a friend of Briley Lynn Lewis.
Okay.
And gentlemen, we'll do it again in a week. Thank you very much for convening for me and teaching me a lot, and take care of your lovely wives. And let's all get back together and take those masks off. See you next week. Thank you, Jerry.
Yeah.
Bye.
Bye.
Hey, everybody.